Welcome to LIS754, Systems Analysis and Design, and in this session we are going to be talking about systems architecture. We're going to start by defining what we mean when we talk about systems architecture. We're going to look at different types of architectures. We're going to look at some examples, and then we are going to talk about how exactly we are going to develop architectures for the systems that we are working on. First, I would like to place systems architecture within the systems development lifecycle. You may remember that we spent some time at the beginning of our class looking at different methods of developing systems, and the systems development lifecycle is a key component of that process where we think about design, requirements, design, implementation, etc. That it's a cycle that we go through. And so this is a different way of looking at it, a more linear view of a systems development life cycle, but we're just sort of right moving from stage 3, the requirement specification, which is what you've been working on all this time, going through and thinking about your defining your project, developing your use cases, developing data models. All of that has been the requirement specification. And we're just going to spend 1 week thinking about some of the technical systems, sort of moving from requirements to the technical design, to the logical design of how a system is put together. And so we're right at that stage where we're just leaving the requirement specifications. So we've made a lot of progress this semester on your projects. Well, when we think about architecture in general, we think about a blueprint, right? A plan for a building. How are we going to develop and create a new structure? And within the field of architecture, it's a very technical field, and it's an artistic field. So both of those things come together. And in systems architecture, it is a technical plus a user center plus a creative design activity, very similar to architecture for buildings. And we have different types of architectures. When an architect designs a building, he or she will make multiple views, multiple types of architectural drawings that convey different information. And so when we look at this picture, this is a 3D draw. Well, it's a 2D drawing, but it's trying to show the three dimensions of a physical space. And we can see how the walls are shaped. We can see how the space is going to look with the windows. This is very much a conceptual model. But there are other architectural drawings that are very, very technical, that lay out exactly the space in numbers of feet and inches, that show where all the infrastructure is, that can show plumbing plumbing features, electrical infrastructure, all sorts of things, where the insulation could go. Talks about materials, that these should be 2x4s, these should be 4x6s, these should be 2x12s, whatever the technical requirements for building the strength and the security of this building. So this is a very, very analogous to systems architecture. One of the most famous examples of architecture is this house called the Winchester House. It's in Southern California, often called the Mystery House. It was built by a woman named Sarah Winchester, who was the widow of the gun manufacturer. She started building this house in 1884, and it was finished in 1922. And you can see from the picture here that it really is quite an impressive structure. It's for its time, it really had a lot of innovative external architectural features, the turrets and the towers and the things. Really quite a beautiful house from the exterior. But it's a really crazy house. There was no architect involved in the building of this house. So out of the 160 rooms in this house, 40 bedrooms, etc., there are 65 doors that go nowhere, 24 skylights that are in floors, 13 staircases that don't go anywhere because it wasn't architected. It was just built. And so we take this as an example of why we need an architect. We need an architect because if we don't, we have stairways that go nowhere. We build in a skylight in a floor that will never get sunlight. So we want to have an architect so that we have a plan, so that we don't waste resources, that we don't make things harder to maintain over time. I'm sure that putting a new outlet, electrical outlet in this house is going to be a nightmare because where are the outlets? Where's the infrastructure for this? So it's really problematic. There's a funny video on the Canvas site that will give you a tour of this house. It's completely optional, but it's pretty, I find it amusing. So when we think about architecture for a software system, this architecture defines a system in terms of its components. What we are trying to do is lay out components and the interactions between those components. And we can do this model, this conceptual modeling, in a variety of ways. We can do it to show the structure of a system, the technical structure of a system. We can do it to help define some of the more technical behaviors and the very high level functional behaviors. And we can do it to show technology, the actual technology that is going to underlie and support this software system. And just like a blueprint is, the systems architecture is a communications vehicle. It is a document to help us understand the different relationships between the components. In most cases in a systems architecture, we abstract the details. That is, we generalize and we leave out details that just make things more confusing. There may be certain views of the system architecture where we need all of those details. So just as we had that lovely drawing that showed the three-dimensional space, that's an architectural drawing. We can also have architectural drawings that show all this detail. If we have too much detail, even in a drawing like this, it obscures the details can get lost. So even in a house architecture like this, they will have a specific drawing just for the electrical. They'll have a specific drawing just for the plumbing, if it's a complex plumbing issue. But so they'll have multiple views, and that's what we're really looking at. We're going to think about the different views of a systems architecture. So when we talk about it, there are some common elements to an infrastructure. Clearly, we want to define the major components. And what are components? Components are things like user interfaces. Components are things like business logic modules. So how do we divide up? How do we organize our software into logical components that can be developed and executed and put inside of this and described with this architecture? The relationships and interaction between different components that we have. Again, this is about trying to remove some of the details to make it clear to people. We only want the details that pertain to the interaction between the components. An architecture helps us organize the system. So we've gotten through all, right? We have all of our use cases. We have our primary functions. We've got a process model. We have all of these things. Now we have to figure out how we're going to actually organize all this data, go back and look at all of those components that we've built, all those different documents that we've built, and figure out how we're going to actually organize them. So we want to talk about what kind of an application we're going to build. How are we going to distribute this this system? Is it all going to be on one computer? Is it going to be on multiple computers? Are there going to be computers in different parts of the organization that talk to each other? Are there different systems that have to be included in this? This is part of this architectural deciding on what the architecture is. We're going to want to think about this in terms, there are multiple views, a conceptual view, a logical view, a process view, how a developmental view, how are we going to actually develop this system. We want to look at this at a conceptual view, and we'll spend time later in this session talking about what we mean by that. One thing that an architecture does is it helps us situate the system within a larger context. So we've been thinking about our system at pretty low level things. The system is, we're going to log on this way, we're going to enter data in this way, we're going to, it's going to be stored in the database this way. But now we need to think about fitting it into the architecture of the larger organization. So sometimes an organization will have a model that they want to use all the time. Client server, distributed. There's all sorts of these models that we're going to spend time talking about, but we're going to take our system and we're going to fit it into one of those kinds of a model. An architecture can think about things in the small, that is, at a low level. We can architect individual programs, how a specific program is going to deal with data, how it's going to deal with the input, how it's going to process. But most architecture thinks about things in the large context of the enterprise, of how all the systems and programs are going to interact with each other, and how they are distributed, and how they are managed, and how they are owned. And this might seem daunting, but I promise by the time we are done, you will be able to do this. You will be able to draw an architectural view of your system. The one thing that an architecture helps us start thinking about are some of the non-functional components of a system. So all the time that we've been working so far, we've been really thinking about the components, about the functions. The system is going to do this particular thing. It's going to take a phone number and it's going to edit it this way. We're going to take people's names and addresses. We're going to make connections between these people and courses that they're going to take, or we're going to associate them with products that they want to buy, or we're going to send them this kind of information. All of those things, those functional points are fabulous, and we've got them now pretty well set. But now we want to think about things like performance. How quickly should our system respond when somebody hits enter? What kind of availability does our system have? Does it need to be up 24/7? Can it be down for 20 minutes a day, randomly throughout the day, sometime in the middle of the night, so we can make copies of the data? How secure do the systems themselves, not what you've been doing in terms of access control, but some of those other issues of security? What kind of a firewall do we need to have with this? Do we need to have separate hardware security for the data, or separate security for the user interface? At what point do we want to insert hardware and other types of security into our system? We want to think about, when we're doing our systems architecture, about how do we make this system easier to maintain? How do we make it so that it's not hard for the programmers to keep this functional? How do we make it so that we can move our software from one computer to another, or from one database manufacturer to another, etc.? So all these kinds of things are really important and get considered while we're designing our architecture. So this is really an iterative process with the functional requirements, the things that we've been working on all semester, and those quality requirements of reusability, of security, maintainability. In my experience, this is a group effort. While there is often someone whose title is software architect, this is an iterative process with many people involved, wanting to balance functional requirements, quality requirements, and also cost requirements. So if we need to have our system available 24/7 with no downtime ever, sort of like banks like to have their systems that way, there's a number of systems that really need to be, hospital systems need to be up 24/7. So that requires a lot of extra money to make a system really be that bulletproof, that you never lose any time, that it's always available. You need extra computers, you need more software, you sometimes need extra people. It can take a lot of extra energy and time to make a system work that way. If that's the requirement, if that's really needed, then we have to really up our quality. And that changes the architecture, and that changes this entire process. I have, will just say that this is generally a process that takes a number of weeks of meetings once the requirements are done, or as the requirements are being developed. This architecture process takes place. It's a big process, and it's one of my favorite parts of developing a system. I really like where we take the functional and we mesh it with the technical. I find this to be a really exciting part of a system development process. So architectures are not always developed from scratch. Systems often have there's an architecture that lends itself to a specific type of system. So if you have something like a transaction processing system, so sort of like a bank, right? I put money in, I take money out. There's lots of little transactions that get sent to a system, like a banking system, insurance systems where you've got lots of claims that get processed. There are system architectures that lend themselves to that, to supporting that functional set. And most of the systems in that domain, banking and insurance, have a similar architecture. They have been set up that way because it just makes sense to do that. If you look at the architectures for online retail systems, they are architected in a very similar way, where they deal with the user interface in a specific way. They've got a middle layer that takes care of all sorts of functions. So there's lots of the architectures. Once you've gotten used to systems architectures, you can look at a system and think, oh, this would fit in a certain type of model that we're going to spend time talking about. One of the most common ways that we think about systems architectures is in terms of layers. We like to think about how we can model an architecture to have layers that provide a set of services. This has been prevalent, I'd say, for the last 15 years or so in systems work, regardless of the type, the actual operating system, regardless of the programming language, the data technology. There is this general notion that having layers, of having, or tiers, sometimes they're called tiers or layers, helps when we set up our system, helps it to be easier to maintain. So if I have, I'm going to show you a layer. This is what a general layered architecture would look like. So we would have one layer for the user interface. We would have one layer for authentication and authorization. We would have a layer for the business logic. And then we'd have a layer for the operating system or the databases or whatever kind of data store we're going to have. And this is often called an N-tier architecture. And we have a video specifically on N-tier architectures on the Canvas site. N, the number, the letter N, a dash, and the word tier, T-I-E-R. We do this, we like this idea of a layered architecture because if I need to swap out a database, so if we're using a database technology, one database technology from one vendor, and they go out of business, or we don't want to use them anymore, we have a strategic arrangement with another vendor, we can swap them out. So if I have an Oracle database and we want to move to SQL Server, if I have my system layered this way, I can swap that out with only changing this layer of my system. If every program that edited data had to talk directly to the database, I would have to change every program, right? So if I can organize my software, if I can organize my system to have one layer, one set of programs that updates the database, all I have to do when I change databases is change this one component. If I have a user interface that uses a certain web technology or a certain programming language or uses a certain model and I want to change it, then all I have to do is change the user interface level. I don't have to change my core business logic if that's not changing. If I'm only swapping out technology, it's so much easier if we use this layered model. And this is the architecture, so using that same model of user interface, authentication, core business logic, database. This is what this would look like. My web browser interface, so that's where all my HTML code to produce my HTML code, everything else. This is my interface manager, how I log in, how I manage the forms and the queries. These are my business logic. I have accounting, I have a rights management, document retrieval. I have an index that's dealing with my data, and here are my data bases. Here's another view of a tiered architecture. I have application logic, I have servers, I have data servers, I have hardware servers. So this is another N tier. So if I have whether I have two layers or 3 layers, it really depends on how I want to organize my data. But this is a very traditional over the last 10 to 15 years view of a systems architecture. And in fact, most of the systems that I have worked on since 2003 or 4 have used this kind of layered architecture. This is a system architecture for something, for a system called Koali, O-L-E. This is for an open library system. And Koali is a very, very large open source project between a number of very large universities that have built accounting systems, general ledger systems, research management systems, and now a library system. And this is it's really one of the most largest and most successful open source application systems that I've seen. I don't know of any that I would consider quite as large or successful or well adopted and well supported. So it's really interesting. So they have the same type of architecture, a presentation layer, which relates to the user interface layer, a business logic layer, and a database or data management layer. So this is a 3-layer architecture, and this is where all of the code for talking directly to the database is located. This is all the code that supports all of the application, and this is for all of the for building and managing all of the screens, the user interface, web page. I'm using screens with, finger quotes, screens for the system. This is a little more complicated of a architecture, and we'll actually talk about this in detail in a subsequent video, but I did want to show you the layers for this system. There's discovery and access, so again, analogous to the user interface layer. Service management, again, the business logic, but this is divided. This is a different organization that we'll talk about later, and data management. So you can see that people like this idea of 3 tiers. 3 tiers. Some have more, some have less, but 3 generally works out very well. There are more videos to come that should give you more details about this. Please let me know if you have any questions. Talk to you soon.